Hi everyone, welcome to the presentation of the special track paper मेरे account में कितना balance है on building voice-enabled banking services for multilingual communities. We're at Carnegie Mellon and I'm working on this with Professor Alan Black and one of his PhD students, Sai Krishna. So what was our motivation behind this work, or what is exactly our work? We wanted to build a voice-enabled banking service for multilingual communities, and one perfect example of such a community is India, where a typical banking interaction in Indian languages is characterized by a lot of code mixing with English. And depending upon the area, the code mixing, the matrix language for the code mixing can be the native language or English, but is mostly the native language. Using and we want to do intent classification, or we want to do this banking this typical so we want to do this banking interaction using hypothesized phones. So we want to convert the audio into approximate phone units and use those phone units to do intent classification. And this becomes especially helpful in the case of low resource languages where we don't have enough data to build robust speech to text systems to build such uh, banking services. And these interactions in India are inherently code mixed. So firstly, we do not have enough data for the low resource languages, but we also do not have enough code mixed data. So for data collection, what we did was we built a dummy banking app, and we collected multilingual code mix data from users when they interacted with our dummy banking app. The interaction was done in two stages. In the first stage, the user interacted with the app in English, and we used the Google Dialogflow API for doing speech to text and classifying the intents. So that's how we got label data. The intents were things like send money, check balance, withdraw money, etc. The usual banking intents. And then once we had the data for English, we asked the user to repeat the same conversation in another language, in another Indic language, if they spoke one. So and for this process, we ask the user to first listen to their entire conversation sentence by sentence, and then repeat each of the sentences in the other in another Indian language. And the aim here was to build pseudo parallel data so that we not only have label data in Hindi but also in other languages. So this is the data that we used for the work that's published in that we submitted at the conference. We have 5 intents: send money, check balance, check last transaction, withdraw, and deposit money. And we have 25 utterances in total in our data set. So, and each of these utterances, for example, an example utterance is मेरे account में कितना balance है. So that's an example utterance that's present in this data set. The pipeline is very simple. We take in the user audio, we generate approximate acoustic phones, and once we have a transcription of the audio in terms of phones, we use those phones for intent classification. To generate phones, we use Xunjian Li's work, who's another PhD student at Professor Allen's group at CMU. We use the system which he calls Allosaurus, which produces does universal phone recognition with a multilingual allophone system. Now, we use these phones for intent classification. And these are the results for the intent classification task. We use naive-based classifier with absolute discounting, and we see that we get our best results when we combine the unigram, bigram, and trigram systems. And the different deltas in the combination, so the 3 things in the combination describes the delta for absolute discounting for unigram, bigram, and trigram respectively. We see that we get decent accuracy, deployable accuracy. Before that, the way the accuracy is calculated is that we have 25 utterances in total, and for each test case, we basically do cross validation where we leave two utterances out, and this is the average test accuracy over the entire cross validation process. So, what do the results tell us? The results do show that we get deployable accuracies for intent classification using approximate acoustic phone units for code mixed Indic languages. Now, the immediate question we have next, that comes to mind next, is okay, so the data set was way too small. Will this technique work with a larger data set? And that's exactly the question that we had in mind, and that's exactly what we did next. So we picked Google's Taskmaster 1 dataset. The dataset is basically a two-person spoken dialogue using the Wizard of Oz methodology. Here, the user is talking to a dialogue system, but the user does not know that the dialogue system is basically another human is operating as a dialogue system. But the user thinks they're talking to a dialogue system, and that's how they're talking. And the interaction is in English, and there are about 5,500 dialogues. And we convert this data set into an intent recognition data set. So our intent recognition data set in the end has approximately 3,200 utterances. The data set looks somewhat like this, where we have six intents: ordering pizza, order repair appointment, calling a ride service like Uber, Lyft, ordering a movie ticket. This intent class is especially difficult to classify because people who watch all kinds of movies, and sometimes people just uh, say the name of the movie to the dialogue system. So they won't even say, "I want to watch Iron Man." They just say Iron Man, and that kind of makes the order movie ticket intent a bit harder to classify. But uh, yeah, but we still do it. And there are two other intents: ordering coffee and restaurant reservation. So for each of these intents, we keep 50 utterances, we remove 50 utterances randomly for testing. So we have out of the 3,200 utterances we have a decent 90 to 10 split between training and testing data, where we have 2,900 training utterances for training and 300 utterances for testing. Now, another thing about the data was that although the data set was two-person spoken dialogue, this data set is actually a text transcription of the two-person spoken dialogue in English. So we this is what we do in data pre-processing to make this data set uh, conducive, or to make this data set suitable to what we're doing here. We take each dialogue and we use the Google Translate API to do a translation into Hindi, Gujarati, Bengali, or Marathi, either of these Indic languages that we test, either of these Indic languages, code mixed with English. And when we get the translated dialogue, uh, we use text to speech to get an audio output. Now the translated dialogue is code mixed; it's not just one language, and we use for text to speech we use Google Text to Speech API, which contains text to speech services for Hindi, Gujarati, and Bengali. Marathi isn't available for Google TTS, and for that, for Marathi, we use ClusterGen, which is another work by Professor Alan Black, synthesizer built by him, and we get an audio for each of these languages. We have two voices for them. One is a male voice, and one is a female voice. So the pipeline looks exactly the same. We use the post-processed audio. So we had English text transcripts in the dataset. We translated them into Indic language code mixed with English. Then we did text to speech. And now from the text to speech, We have in order data, we generate phones out of it. And once we generate phones out of it, we then use that transcript in terms of phones for intent classification. Now, the results for the intent classification are promising. They support the results of our initial study. The intent classification in this case was done using naive Bayes with absolute discounting and advanced smoothing. In the first column, we present languages. In the second column, we present the n-gram naive Bayes classifier with a value of delta. The n-grams is equal to 3 in each of these cases, which tells us that the trigram naive Bayes classifier gave us the best results. And the delta, when delta is equal to 0, it means that advanced smoothing gave us the best results. But when delta is greater than 0, it means absolute discounting gave us the best results. And for Bengali and English, absolute discounting gave us the best results. The test accuracies are high and comparable, and actually they're better than what we had for the banking system. So in this exploratory work, we show that we can use approximate acoustic phone units for intent classification. Now, this becomes especially useful in low resource scenarios where we do not have enough data in one language, or enough code mix data even, to be able to do intent classification, or just to be able to build a robust speech to text system to do downstream tasks. And in those scenarios, using these phone units for intent classification systems, or for building different kinds of services, spoken dialogue services, becomes especially useful. Now, some of our future work or current work, I should say, is using neural nets for intent classifications. For these, using the hypothesized phone units, we are also testing this method with different language families. For example, the Romance language family, and we're also we're also testing a method in multilingual settings in a code mix scenario. We for example, we train our system in Hindi in 2 languages and test it on a third language. So we're training it on Hindi and Gujarati, for example, and we're testing it on Marathi. So this is basically, we're doing it for low resource language, but we're also doing it for we're also creating a system and testing it for a language that has absolutely no data. And we're seeing how much of it can be learned from similar languages. Like for Marathi, how much can we learn from Gujarati or Hindi, such that if we do not train on Marathi, how good results we get. So we're testing on multilingual settings, and and for languages that we have absolutely no data for. And that's it. Thank you, everyone. These are the references, and thank you, everyone.